हेलो स्टूडेंट्स, गुड मॉर्निंग टू ऑल। अभी तक हम लोग थर्मल प्रॉपर्टी ऑफ मैटर में पढ़ चुके हैं। व्हाट इज हीट, व्हाट इज टेम्परेचर, डिफरेंट स्केल्स ऑफ टेम्परेचर, व्हाट द इफेक्ट ऑफ हीट, that is on expansion of material, expansion of solid, its linear expansion, superficial expansion, volumetric expansion, then on their latent heat during change of their state, latent heat of fusion, latent heat of vaporization. Correct? Today we will study on what is principle of calorimetry. Principle of calorimetry. As you know, calorimetry indicates measurement. It is linked to measurement of heat. Measurement of heat. This principle of calorimetry says when two objects at different temperatures T1 and T2, suppose one is at higher temperature, if T1 is greater than T2 and both are in contact, that some heat will transfer from hot body to cold body. That means some amount of heat energy will be lost by or given by hot body. This is suppose hot body and this is cold body. Now they brought together. Once they are in touch or in contact, some heat energy Q will transfer from hot body to cold body. The amount of heat that will be lost will be equal to the amount of heat that will be gained by cold body. This amount of heat energy gained by cold body will be amount of heat energy lost by hot body. This is our principle of calorimetry. This is amount of heat energy gained by cold body is equal to amount of heat energy lost by hot body. This says about law of calorimetry, or it is called a principle of calorimetry or law of mixtures. This is principle of calorimetry or law of mixture. Now we'll study on what the Kirchhoff's law on heat transfer says. Says Kirchhoff's law. We have studied about heat transfer in solid through conduction, in liquid through convection, and through when no media is required, that is through radiation. That is through radiation. In radiation, no media is required and heat transfer from one place to another without any media, and it transfers in the form of wave. That means in radiation method, heat transfers as a wave, that is electromagnetic wave. It transfers as an electromagnetic wave and it moves with certain wavelength. That is, suppose wavelength is lambda. That means when heat energy transfer from A to another location B, here no media is required. That form of transformation is called radiation. That method of heat transfer is called radiation. Radiation itself is the radiant energy. Radiant heat energy. What is this radiation? Radiation itself is the radiant heat energy. That itself moves from one place to another as an electromagnetic wave, and that particular it is associated or it moves with certain wavelength. Like it is a wave from here to here, we say its wavelength, and number of such waves per second, we say frequency, that is frequency, and that means it moves like our light moves. As the frequency is very small, as the wavelength is very small, we say light, heat also transfers in straight line, in straight line, and does all reflection and diffraction, and diffraction means it also moves or transmits through any inside the medium, any transparent material. It gets reflected also, this is reflected, it gets reflected from any shining or reflecting surface. It moves through any transparent media. In addition to that, it gets absorbed by the particles of the object. We say it is some part of the heat energy gets absorbed. Correct? That Kirchhoff's law says for any media, for any object, when it receives, some radiant energy, suppose this is object 1, another object is kept, and it also receives some radiant energy, or we say radiation. In this case, it is emitted by somebody. We say it is coming from surrounding. This radiant energy now gets incident on the object. As you know, few of or fraction of this radiant energy get absorbed. Here it is incident, now some part is absorbed. So Qy is radiant energy or radiation fall on the exposed part of this object. Qa, the amount of radiant energy get absorbed by heat. In similar manner, for object 2 also, Qi gets it depending upon the exposed part. If both are of same dimension, then this Qi will be this Qi. If they have different dimensional shape, different dimension, exposed area is different. इसका जो area exposed है, if it is not equal to this one, then both will have different QI. Suppose now both have same dimension or same external size, external area. We would say it is external surface area. Then in that case, if external area is A, here external area is A, then this incident amount of radiant energy will be this amount of incident energy. Now, the part of our heat energy that will be absorbed depends upon the material of this object, and part of this QA2, here it is QA1. This QA1 and QA2 will be different for different objects. Now, after it is absorbed, जो एनर्जी absorb हो गया है उसी में से ही it will start emitting. We know the amount of that heat, amount of radiant energy that gets emitted by the object. We say it is emissive power. Now, what is absorptive power? Absorptive power of an object we have studied is amount of heat absorbed with respect to amount of heat incident. Now, for object 1, it will be AP1, it will be QA1. For object 2, objective power 2 will be QA2 by, again, QI is same for all. Let it is Q now. Amount of heat that is incident due to same set. Now, the amount of heat that will be emitted, we say it is emissive power E1. In this case, it is E2. This is absorptive power A1. It is A2. This emissive power depends upon surface area and emissive power is as we know, the amount of heat will be emitted, amount of heat that will be emitted by an object depends upon the amount of heat it has absorbed. So in this case, what happened? Q emitted 1 is equal to E1 A time. Suppose we are considering for a fixed time t, here t time is t second, here also time t second, then amount of heat that will be emitted by object 2 will be E2 surface area